Okay, it's Moser with hints and tips on your 4C worksheet problems. This is for number 8 on the 4C worksheet, and we're talking about the Egyptian driving test. Pass the test, drive forward 6 meters, stop, drive the same distance in reverse. Now, we're told that at the end of 6 meters, the car's brakes are suddenly applied and the car slides to a stop. Well, if the force required to stop the car is 6 times 10 to the third newtons, and we're given the coefficient of kinetic friction between tires and pavement, 0.77, we want to see if we can find the magnitude of the normal force and the car's mass. First off, we should understand the situation. You may be surprised to see only the force of kinetic friction drawn on this free body diagram, because in fact, friction is what stops the car. Oh yeah, that's why you can't stop on ice, because ice drops the coefficient of friction. So, having that free body diagram, we also have to remember that we've got 3 equations we can work with. Mu k equals Fk over Fn, sum of forces on the y, sum of forces on the x. Now, in this case, we probably aren't going to need all of them, but it's a good idea to just remember that these are sort of the 3 tools you have in your tool bag to solve these kinds of problems. Let's start off with the mu k expression. So, mu k is equal to Fk over Fn, and we're given mu k, and we're given Fn. Well, that should make it pretty easy to solve for, Fk. That should make it pretty easy to solve for Fn, which we can do by rearranging the equation. Now that we have that, we still need to know the mass of the vehicle. So we know that this thing is not rising or sinking, therefore sum of forces on the y is 0, and the only forces present on the y are normal force and force of gravity. That means that we can express safely that Fn equals mg, and since we know Fn, we can divide that by g, getting mass. All right, keep going.